Welcome to doassignment-ca. Here is the problem. An elevator starts from rest at ground level. It can accelerate at 5 feet per second squared and then decelerate at 2 feet per second squared. Determine the shortest time it takes to reach a point 40 feet above the starting position. The elevator starts from rest and stops at the upper level. Draw the acceleration time, velocity time, and position time graphs for the motion. Now, let us work through the solution step by step. The elevator has two phases. First, it accelerates at 5 feet per second squared from rest, then it decelerates at 2 feet per second squared until it stops. For the shortest possible travel time, there is no coasting phase. The elevator goes straight from accelerating to decelerating. Together, the two displacements must add up to 40 feet. The peak velocity must be the same at the end of phase 1 and the beginning of phase 2. During acceleration, the peak velocity equals 5 times t1. During deceleration, it equals 2 times t2. Setting these equal gives t2 equals 2.5 times t1. Now we write each displacement in terms of t1. Phase 1 gives 1/2 times 5 times t1 squared, which is 2.5 t1 squared. Phase 2 starts at the peak velocity and ends at rest. Substituting t2 equals 2.5 t1 into the kinematic equation gives 6.25 t1 squared. Adding both displacements and setting the sum equal to 40 feet, we get 8.75 times t1 squared equals 40. Solving t1 squared is about 0.571 seconds squared, so t1 is approximately 2.138 seconds. From t1, we find t2 equals 2.5 times 2.138, which is about 5.345 seconds. The total time t is the sum, approximately 7.48 seconds. The peak velocity reached at the transition is about 10.69 feet per second. Checking, phase 1 covers about 11.43 feet, and phase 2 covers about 28.7 feet. Their sum is exactly 40 feet, which confirms our answer. The acceleration time graph is a two-value step function, +5 during acceleration, then -2 during deceleration. The velocity time graph is a triangle shape. It rises linearly to the peak speed, then falls linearly back to 0. The displacement time graph consists of two connected parabolas, concave up during acceleration and concave down during deceleration, smoothly joining at the transition point and ending at 40 feet. To summarize, the acceleration phase lasts about 2.14 seconds, and the deceleration phase lasts about 5.34 seconds. The shortest total time to travel 40 feet and come to rest is approximately 7.48 seconds. The peak speed reached is about 10.69 feet per second. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.